welcome to chapter 2, part 7 of this course. This course is very big, it's huge. So we're taking it gradually. Chapter 1 has several parts, chapter 2 has several parts. So if you look it all together, we already have 40 sections, only for 2 chapters. So you're welcome. Chapter 2, part 7 for this course is called Troubleshooting Cable System. Now, what we need to do by the network administrator in order to be able to find the problems in our cabling. Now, the first, we have to understand the 2 big objectives for this small subsection. One is to examine some of the issues that the network administrator can have with both the Cat 6 and Cat 5e cables, and all your cable test results. Some of the issues you can find when the test results are out from Cat 5 and Cat 5e and Cat 6. Okay, so the issues you can have from your test result from Cat 5e and Cat 6 cable. Another thing is that it's very significant that the network administrator monitor all parts of the cable installation. You have to monitor all parts of the installation process, from the pulley to the termination of the cables. Okay, you have to follow all parts, because these are areas where the problems usually emanate from. So the administrator must follow through all parts of the cabling in the whole process. Now, testing the installed cable. After we've installed the cable, we have to test to find out whether they meet or they work or operate according to the manufacturer specific. We have to see if the cables are working according to the manufacturer specifications, which are called specifics. Now, what are those parameters that we do need to test in order to check if the cables are working according to specifics? One of it is the power sum. You have to test for the power sum. If you obtain a bad power sum measurements from your cabling, then probably the cables are not working according to the manufacturer specific. Another thing is to test the near head crosstalk. You have to test for the near head crosstalk to see if the cable are meeting to the minimum requirement, at least the minimum requirement. We're not saying the maximum in this case, at least the minimum requirement as designated by the manufacturer. Another thing is the far head crosstalk. You have to test if the cable are working according to these designations as described by the manufacturers. Now, there must be a problem with the installations, right? Sometimes if you test all this, the power sum is not working or is not meeting to standard. The near head crosstalk is not meeting to manufacturer specification. The far head crosstalk is not meeting to manufacturer specification. Then there must be a problem with the installations, because we know cables do have problems, but if everything is not working, then it means maybe installation has a problem. Now, the most common error the installer usually face, or they usually have, is they allow too much or twist cable at the termination point. They have too much or twist, okay, at the termination point. Remember, the twist that is allowed for UTP cables is to maintain something less than about 3/8 inches, right? Just a little bit 0.375, which approximately to 1 decimal place will be 0.4 inches. So something a bit less than 0.4 inches or 0.3, somewhere around 0.3 inches is the maximum the twist you allow for your cable. If this is more than that, the twist is more than this 0.4 inches for category 6, and if category 5e is 0.5 inches, then you begin to have the installation problem. Okay, now let's move on quickly. Cable, let's look at cable stretching. Stretching of the cable is very bad, right? Because it creates a lot of electrical problems. It changes the whole dynamics of the electrical characterization of the wire or of the cables. So, and when this happens, it will increase it will reduce your bandwidth, it will increase attenuations, it will increase crosstalk, and create several other problems that minimize the attenuation to crosstalk ratio. So all of this, when stretch happens to your cable, it's deflate the electrical characterization of the cables. So we don't want this. So we try to arbitrate, we try to resolve, we try to solve this kind of problem, minimize these problems that can come with cabling. Okay, then the maximum pulley tensions is specified by every manufacturer, because before you install cable you have to study what we call the manufacturer data sheets. These data sheets gives all the specific, gives every specific that you need, the attenuations, the ACR, which is the attenuation to crosstalk ratios, the insertion loss, the whatever specific will be mentioned, the return loss, all these specific will be mentioned, the PS sum, the power sum, all these things will PS nest, the nest, PS nest, LFest, all of this will be itemized by the manufacturer in the cable data sheet. So as an installer, a network administrator, you need to study this specific on cables before you embark on installation. Now let's move on quickly. Cable manufacturer specs. So every manufacturer has some specification. Specs means specification. They have specification that you need to abide with. A standard you have to, at least minimum requirement, because after installation you have to test in order for the network to gain certification that okay, everything is working properly and then it's good to go. So you have to follow the specs of every manufacturer, because manufacturers do experience also problems may not even be in the installation process. It could be from the manufacturer's problem, because sometimes cables, when they're manufactured, they do experience problem with failure, cable failure, the mean-time ratio, and all of these reliability or issues on cabling. All these things the manufacturers do have problems. They fail to meet specification standard that they've set for their cables. Now this could be due to bad production line, could be the faulty production line or faulty production run can bring out cables that are not worthy to their own specified values, and the result is that the cables will not meet their minimum specification. So when this happens, the cable themselves will not meet their minimum specification. So when we repeat the test, because repetition in engineering, in science, enhances the level of accuracies. So when we repeat the test and failures keep happening, and this failure, cable failure, result failure, keep being apparent, then we know that the failure could be the case that the problem is in the cable and it's from the manufacturer, not from the installation. Now this rarely happens anyway, where this is there, this problem is there, but it's not like it's every time. The cable failure not meeting its own standard, its own minimum specification by the manufacturer, it's a problem that can happen, but it's not often there. It's not often the case. Now let's quickly look at some tests that were carried out and some of the results. If you look at this whole test result, in summary, this is pass, meaning that whatever parameters that were tested for this cable, it passed. First of all, let's look at the test. The first example here we have is the test on a short patch cable. That was the test. The test was carried on a short patch cable, and this shows that the short patch cable can and should be tested, right? Should be tested. And when that was done, the UTP cable testing is not restricted to long cables. You can also test for the short cases, short cables, short panels, and all of this thing. And when that was done, the length of the wire pairs is about 3 feet, from where you put your modular plug to where you clip it. It's about 3 inches. So that short part, because your near end crosstalk is happening at that point. So when it was tested for this cable, the result both for attenuations, for the equal level far air crosstalk, the result of the power sum near air crosstalk, the result for power sum attenuation to crosstalk ratios, the result from return loss, the result from all of these results show pass success. So this cable one that was said, there are test devices that we use for testing this cable. Okay, as a telecom engineer, these devices will be made available for you, and these values are displayed just like meters. If they are meter, once the cable is connected to it, it will read the values for all the logs. We run them out. So a run result, an output result like this will be displayed. And now once you see these results, and then overall result shows pass, meaning this cable for the short patch panel that was tested is a success. It's a success. Everything from the after the installation was a success. Now, if you look at test 2, if you see the overall result is fail. This cable failed. It did it. What we tested for was not a success. Now, what are the things that was tested? It says this test 2 shows the test on the same 3-feet cable used in test 1. However, the cable no longer meets the standard or the specification. The test results indicate fail. So you can see this result shows fail. So in fact, careful inspections of the cable show that it had been cut or naked. The cable has been cut, had a cut, or is naked. So that's where you're seeing the result output is fail, 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 fail. Okay, fail. So this cable has failed. Okay. So if this happens, we say this result underscores the importance of documenting the network installations and having a record that the cable leak was certified. Because if you have a result like this, you will not go to certify that the cable is working. It's failed, because you have to find what the problem was and how the problem came back. Now let's take a look at test 3 that was also carried out on the cable. Test 3, you can also see that this is failed. The result was also failed. So there's a problem you have to find. Now test 3 examination of the attenuation. Now in test 3 we examine the attenuations and the return loss menu, and these ones they show that the cable failed to meet Cat 5E attenuation and return loss specification, because the manufacturer has already in the data sheet has already specified the values for the attenuations and the values for the return loss. So after carrying out the test using the test meter, and then you find out that these values are not same with the minimum value as specified by the manufacturers. So at the end of the day, your report is that this cable failed to meet standard. Okay, this cable also failed in their near head crosstalk. This cable failed in their equal level far head crosstalk. This cable failed in their power sum equal level far head crosstalk. So all these specifications that were tested, this cable did not meet their standard. Okay, so it's a failed test. Now we go to cable, another test 4. It's also a failed result. Failed result. What was test 4 for? Test 4 examination of the certification report, and this one shows that the cable failed the delays queue. The cable failed the delays queue. You remember delays queue is the time it takes for the cable to propagate in one wire, the time difference between when the cable propagated in one wire of the twist to the time it took for the second one to propagate in the second wire of the same twist. So when that happened, when that failed, then it means the cable exceed the maximum allowed by the standard, which is 568B. 568B, ERTR 568B standard that has been specified. The cable did not follow this specification, or the manufacturer did not follow this specification in the manufacturing of the cable. Maybe they short change the capability, or in order to make profit they manufacture less. They didn't use the required standard. They didn't meet the required standard for cabling, for network cabling. So we look at the net, we look at the length measurement for the 3 and 6 pair length. Now the cable is 1040 feet in length. Remember, the maximum cable length for Cat 5E cable run is 100 meter. So you go to test through the 100 meter and see whether the cable is performing according to what it's supposed to. Now here is the summary of this section. Like I said, this section is a very short one. It's like the crown. We are crowning what we've learned in the whole of the chapter. So in summary of the test is that the reason for examining, why do we have to examine the test result? The reason why we do this is to find out why cable fail a test, whether it's the installation problem or is the manufacturer's problem. You need to know whether the problem is with the terminations, or the problem is with the layout of the cable, or whether the cable is not installed properly. So you need to know, is it the termination point? Was it not terminated where in their modular plug? Were the cable not terminated where in their modular jack? Were the cables not terminated where in their patch panel? Is it a problem? You have to find out. Or was it the laying out of the cable that was the problem? It was not laid out properly. Or the problem was that the cable itself was not properly installed. Or could it be that it's the manufacturer's problem? Okay, so all of this we have to take a dynamic look at and differentially come up with absolute results or absolute conclusion from this test result. Keeping a record of the cable, keeping a record of this cable test will help you to isolate recurring problem. Yeah, you'll be able to isolate them, you'll be able to solve them easily, because every time you carry out cable tests, you have to file a report. As an engineer, you have to file a report, you have to record these things. So whenever a problem happens, you can check what was the problem last time and what were the remedies, the solutions that were profound by probably the then administrator, network administrator. So it helps you to mitigate the problem easily if you keep a record of these test results. Now, test 1 and test 2 demonstrate the importance of keeping a record of tests, because you can see the test 1, the success rate, the test 2, the failure rate. So you can easily refer to them, okay, as your references. In this case, the cable was certified but later failed. In the first case, the cable was certified, the test 1. Test 2, the cable failed. When we carried out test 2, the cable failed. So in this case, the cable was certified, but it later failed. Now, the documentation provided by the certification report provides evidence that the cable was functioning properly at the time of installation, but later did not meet the standard, the specification that it ought to have met. Okay, so this is the end of our short section, and in this section, the big word here was pair data. Okay, thank you very much for your time. We meet in chapter 3. Thank you.